We were going to try an experiment today, but I don't think our network is quite up to the task. We were going to try to do live streaming of tonight's meeting, but I don't think our visitors network is quite robust enough to do that.
Figured out a way.
You figured out a way.
Yeah.
Okay, so we may be live on
On YouTube?
YouTube.
Yeah, Facebook and Twitter as well.
Okay.
Yeah.
So at the end, if you have any questions, there's your chance to be an internet star. We are looking, ALN, like I said, was an all-volunteer organization. We are looking for some people to fill some leadership roles. So when you came in, you should have gotten a comment card, which will take that feedback about tonight's session, and that will also give us information on future sessions, which you would like to see. On the back side, you have the opportunity to fill out your name and contact information and what areas you might like to help the organization. We are looking for a secretary, which is actually an officer's role on the leadership team. And then also, if you're interested in helping out in the sponsorship coordinator, the finance coordinator, volunteer coordinator, marketing coordinator, and speaker coordinator. So we have a lot of opportunities. Wouldn't require a lot of time, but it definitely would be a tremendous help. As I mentioned, next month will be our 10th anniversary. It'll be Thursday, September 20th. Mary and Tom Popendick are going to come to speak. So we're excited about that. They're going to be talking about stop delivering software. Imagine that. Other announcements, we got Houston Tech Fest is going to be Saturday, September 29th at the San Jacinto College. ALN will be there, and again, we'll be looking for volunteers. Call for speakers closes next Wednesday, August 22nd. Check out the Tech Fest website. Actually, I think their website is actually a Facebook page, if I'm not mistaken, but maybe it is a website. And Bruce, you got some announcements? Jobs?
Well, at least one announcement. Yeah, I work for a group called Rice OpenStacks. We're a nonprofit that puts college textbooks online for free and helps college students that way. We're looking for some UX people, UX design people. One by one, all of our UX people went elsewhere to greener pastures. So we're looking for a UX manager, user experience manager, somebody that's got some experience. Plus, there's a 3-month contract opportunity. So if you are a UX designer or know people that are in this field, come see me and I'll give you some information about that. Thanks. Ron reminded me that we do have a functioning job board. If you know of positions that are available, you can send them to jobs@alnhouston.org and they will get posted on the site. If you're interested in being on the list to receive information about jobs, then note it on your comment form. Write the word jobs on there. We'll put you on the mailing list, and every time something comes in, we'll send you an email. So hopefully this will be a way of connecting people in the Agile community with job opportunities in the Agile community.
Thanks, Bruce. As I mentioned earlier, please fill out your comment cards and turn those in before you leave. And tonight's presentation will be made available through our website after the presentation. And once again, our sponsor tonight is Synerzip. Our speakers tonight are from Synerzip. We have Hamad Al-Hens. I will get it right someday. This is the fun one. Vinay Joglekar. Oh, one of these years I'll get it right. So I wish Brianna was here to do this. They are presenting tonight. It is the CEO and CTO from Synerzip. Yes? Okay, got that right. And we have several other folks here also from Synerzip tonight too. So with that, I'm going to turn it over to Hemant and Vinayak to talk about the top 12 takeaways from Agile 2018 San Diego.
Can you guys hear me in the back?
Yes.
Yeah, good. All right. Looks like your mic is also working.
I think Hello, yeah, I think we tested it a minute back. Yeah.
Perfect. Okay. So any of you guys have attended this routine? We've been doing this routine of top 10, top 12, sometimes it becomes top 14 for the last few years. So any of you who have actually attended our previous year's session here? Yeah, many of you have, but some of you haven't. So I'll give you a quick overview of what we try to accomplish here and describe the process, then we'll quickly get to the subject matter at hand. So the conference, the big Agile conference was last week in San Diego. So Vinayak and I run the software company Synergy that Ron alluded to. We do software development services work for our clients. And we've tried to follow Agile practices while we're doing that. And we find a lot of challenge. All kinds of challenge working with real clients. So we try to, when we attend the conference, we go in there seeking clarification and advice and answers to questions, whether it relates to estimation, whether it relates to, how to manage DevOps, whatever, so all kinds of challenges that we run into. And we commit ourselves ahead of time, before going for the conference, that we'll come back with our highlights and share in Dallas, Austin, Houston. So we did that in Dallas on Tuesday. We did it in Austin yesterday, and now practice is done. This is a real thing for you guys now in Houston. So because we commit ourselves ahead of time, it makes us that much more focused attending the conference. And this is a big conference. This is a week-long conference with about 279 sessions over 4.5 days, Monday to Friday noontime or so. And at any given time during the slots of sessions, there are 19 choices for us to attend. So we have to be very actively thinking about what's the right topic, a good use of our time. Each session is roughly 75 minutes. So we are committing significant amount of time. So between Vinayak and I think each of us ended up attending about 15 to 20 sessions each. So total of between 30 to 40 sessions total. So that's the sample. So based on those 30 to 40 sessions that we attended ourselves, and we talked to people in various formats there, we combine our main highlights based on what we're hearing from this year's conference. And we try, at least we make conscious effort to not look at what we said last year. Whatever we said last year, there was highlights then. This is fresh from this year's conference. So with that, let's get started. We'll take our routine would be, we'll alternate. So Vinayak will start with topic number 1, then I'll go through topic number 2 and so on. And you guys ask any questions along the way. So keep it conversational, and we'll try to keep the pace up so we respect the time that we have with us, which is a little over an hour, I think, that we have. So with that, let's go to the first topic.
Hello. I think, I need to get the distance right. Okay. So, the first topic is about 12-factor pipeline. So this is very exciting. So this was a session by Juni Mukherjee of CloudBees. CloudBees are the people behind Jenkins, and they're talking about not only continuous testing, continuous integration, continuous delivery. Sorry. Okay, so we have all heard about this, right? Continuous integration, testing, delivery, deployment. But they're also talking about doing continuous monitoring of analytics and insights that you get. So this has become a part of the pipeline. So what's the point in deploying something if it's not going to make any difference to your customers, the way they behave? So how you would get to know whether you are getting the desired change in the customer's behavior is by monitoring metrics or analytics. So that also needs to be continually done. And then based on the insights that you get in this, you would be having continuous governance. So a picture of that would look something like this. So earlier we used to have, if you see here, it was basically this part, check-in to go live. This was your pipeline. You would have a source control, you check in, you integrate, deploy, and go live. But now we're talking about a pipeline, and in fact, Jenkins has the next version of Jenkins, which manages a pipeline which is from concept to cache, right? So I'll be showing you a picture of the pipeline. So it includes everything from even product owner coming up with the stories and requirements right up to the customers or end users, validating your hypothesis and actually buying or putting cash in your hypothesis to by exhibiting the desired behavior. So this is very exciting, right? So its DevOps pipeline has now got extended right up to, so it's not just that you build something and you feel happy because it is passing all the tests. It has to pass the ultimate test, whether customers are ready to buy what you have built. So that's the exciting part. So this is the picture of the pipeline which I talked about. So you're familiar with this part, right? So you start with build, then unit testing, and then you do some kind of static analysis. Then you take the subsystem and deploy it, and you have some kind of performance and other tests. Then, one thing that is good about this pipeline is this single code base but multiple deployments. So at the same time, you can deploy two versions simultaneously. So some of the customers would, or some of the end users would see version N, and some others would continue to use the old version. So this is like blue-green deployment. Now, if you see that the new version is going well, in that case, you actually roll over to the next version. But in case it's not going well, in that case, you can roll back and keep the old version. So that's the blue-green way. So in fact, what you're doing is you're using your end users as your testers in production. Similarly, if you have a concept to test, we'll be talking in detail about A/B testing. And if you're running an experiment, you can actually have an A/B test as a part of the pipeline. And you can measure what is the outcome in terms of business KPIs or performance indicators. And then depending on which of the two options works better, you would go for either your option A or option B. So you can imagine that this is the entire pipeline, which used to end somewhere here. Now it has become a much longer with A/B and blue-green kind of deployment. So these are some of the principles that she highlighted. There were 12 of them. I'm not going to go through all of them. So important one is one code base and many deploys, which we talked about. So you don't have branching. So since you have the ability to simultaneously you can have coexistence of multiple versions in the same code base. So it is possible. You don't have to have branches. You have only trunk deployment. You have strictly separate build, release, and run stages. Okay, and then you store configuration in the environment. You don't usually you're used to have configuration stored in some kind of XML or YAML file. So instead of that, you have a configuration server, and you don't put it along with the deployment in the same instance. Backing services as attached resources, maybe in S3 buckets, etc. So as you would see, these are the same 12-factor principles that you apply to microservices are being applied now here to the pipeline. And concurrency and disposability. So it's easy for you to kill services in case they are not working properly if the producer is not aware of all consumers. So in that case, you have a producer-driven contract, and you can kill the producer without impacting the consumer, because really speaking, the consumer is consuming off a queue. And if the producer produces, that is asynchronously put in the queue. So if the producer dies, it doesn't leave a consumer hanging there, waiting for a response. It is actually listening asynchronously to a queue. So, and also you don't require end-to-end testing of both consumer and producer. In this case, only consumer can be tested. So these are some of the advantages of disposability. And they announced Jenkins X. I have not tried it, but I'm going to try out as soon as So one thing about this conference, why I go to this conference is, it's like, I'm like a cell phone. tend to get discharged over 1 year. So I attend this conference every year to get myself to recharge. So initially I have a lot of energy. Okay, let me go and try all these things, and then by the time it's July, August, again I need to get recharged. So I come back here and go back with so many ideas. So Jenkins X is one such idea which I'm going to try out. I'll come back next year and tell you what happens. So good part is I would like you to take a look at Helm, which is a part that is a tool that is managed by Jenkins. Helm is nothing but a packaging tool which packages distributed applications. So if you remember a few years back, you used to have CDs, and shrink-wrapped CDs could be put in your laptop or PC, and you could install and run your software, and that is how software was distributed. But once you have distributed systems which are cloud-based, it is impossible to do that. So you have to go for a SaaS or a subscription model, right? I mean, you can't just give something away, which with a push button that you push that button and it can get deployed where you want. But that is possible with Helm. With Helm, you will be able to package your application which runs on top of Kubernetes and deploy it on whichever cloud, whether it is Azure, whether it is Google, whether it is your private cloud using OpenStack or Cloud Foundry, doesn't matter. So that's a big thing, and Harbor is the next thing that I would like you to take a look at. Harbor is, it's like a market, like you have App Store, you have a market where you can actually download or take these distributed applications and pay for them in cryptocurrency. So truly speaking, this Jenkins X is actually managing concept to cache, right? So it could be possible for a developer to put up their distributed application in the marketplace and get paid for it, from including testing the application, validating and everything. So that's what is exciting about this. And this is I thought this was a big news that got me excited this time. So let me give it to Hemant for the next one.
All right, so our next takeaway from the conference was this topic of Agile Quantified. So this, I forgot to mention in the beginning, there was a new track this year of the 20 tracks called Agile Data Metrics track. So you'll see a lot of our takeaways relate to data and metrics because there's a full track this year on this. So Larry Macaron, I don't know if you have been familiar with his work. He has done detailed research and analysis of practice data going to about 10,000 teams from Rally Software. So he's done his PhD in this topic of data and analytics at CMU, and then mined a lot of the data, real data of practicing 10,000 teams from year 2011 to 2014. So what I'll share with you are some of the main salient observations based on that data that he shared. And to define the performance of teams and connect them, correlate them with certain aspects of Agile practice, they defined a very balanced criteria with 4 considerations for it's called Software Development Performance Index. One measure is productivity, which is how much work team is getting done. Number of stories or number of story points per sprint, and some measure of how productive the team is, and then some measure of predictability, which is how stable their output is of a team. Which is if they do 4 stories one sprint, do 9 stories the next sprint, and then do 2 stories, that's not very stable. But if a team is able to have a consistent velocity, then that's predictable. So that's one example of predictability metric. And then responsiveness, meaning how quickly can you get a story from being ready to be developed to in the hands of and to go in the hands of a customer. So the cycle time, essentially. So that's the responsiveness of a team, and then quality of their output. Could be defect density, could be number of escape defects and all that. So they define a composite performance criteria, and on these performance criteria, we'll share some of the highlights. So, but before I go to the highlights, this is an important caveat that he highlighted, and I'll repeat here, which is make sure there's no such thing as best practices, but we're sharing here. These are good practices that you can apply in your context, and you'll see what context means in different situations. And then, of course, correlation does not necessarily mean causality. So just keep that in mind. But that said, some of the data here that I'll go through 6 such highlights, very useful. So the first one is team size. You see here, we've all known that for the composite performance, these are 4 colors of the 4 criteria I just mentioned. So Orange is quality, purple is responsiveness, blue is predictability, and green is productivity. So on that, all those balance considerations, the best performing teams are of course the two pizza team, 7 plus minus 2, which we have all known for a while. But the important kind of takeaway from this data and what covered in the keynote address by Troy is the fact that, if a little larger team, 9 to 15, may still be fine, it's not that big a difference in the overall performance if it reduces the number of dependencies between the teams. So it is okay to have a larger team if you're going to reduce dependencies, because that really slows the process down. So that's one takeaway on the team size, which is not just 7 plus minus 2, but up to 15 seems to be still pretty productive teams. Second takeaway on the length of iteration. So the takeaway here is longer iterations, which is 4 weeks or more in this curve, tend to correlate with better quality. And so the orange color is quality. This is the quality chart. And shorter iterations relate with higher productivity and responsiveness. So if you have shorter iterations, you have higher productivity and responsiveness data. I'm not showing right here. And overall, 2-week iterations seem to be balanced. So the idea is, if you're building an early stage product, you're doing an MVP, go for shorter iterations. You're going to do it faster, productivity will be higher, will be more responsive. If you have an enterprise class software product, quality is the biggest concern, maybe longer iterations are better. So that's what data seems to. And remember, this data is a pretty robust 10,000 teams worth of data, and we'll put through a fairly rigorous statistical filter before being kind of shared as a finding. And none of these findings are ours. These are Larry's findings. We're just relaying them as the highlights. Because some of these charts are not as, given the scale, they're not as obvious, but the findings are still pretty robust. Okay.
Are the lines up on top of the bars the range?
The range, yeah, the variability.
Plus or minus signal.
Oh, okay.
Yeah, that's an important point. Yeah. So in this case, the quality is defect density. Number of defects per team member per sprint, something like that. So that's the one they chosen in this case for quality metric.
And you said 5 plus weeks, 5 plus the
Yeah.
outbound.
Right. Yeah, so on the longest iteration. Yeah. I don't know what there was in the data. Yeah. So that's one challenge of this data. He has to massage the data. We have 10,000 teams over 4 years of data. So to actually get them to a point where you can draw some signal out of that variable data across multiple, these are anonymized data highly. So just conclusions are important. Yes, sir. He didn't go through that detail in here, not in the. But so more important answer to this question is, you should look up most of this information is publicly available. If you just do Google search on STPI or Larry Macaroni, you'll find PDF document and his presentations and all that. So I encourage, if you're actually interested, beyond our highlights that we're sharing, just read that stuff. It's pretty readable and has a lot of interesting next level detail. And we're trying to do that, and these highlights provide reference wherever possible, links and references, so you can just, if any of these points you find more interesting, most of this is publicly available stuff. Okay, so moving on to the next highlight from this data, the ratio of dev to QA. So the axis here is 0 is meaning you have no QA in the team. 0.3 meaning the ratio is 0.3, meaning 3 dev, 1 QA. This is 2 dev to 1 QA, and this is approaching 1:1 dev to QA. So on that kind of a scale, you see that more testers, So if you have more, if you're close to 1:1 QA, of course you get higher quality here in this case. But you also, if you have higher QA, it generally leads to lower productivity and responsiveness. And the teams that have self-identified in this data as having no QA, they seem to have they seem to have pretty good productivity. They have no QA, all developers, but also have almost as good, if you see here, as good, close enough quality. And the explanation is these are developers taking ownership for quality. But the interesting thing I find in this also is the huge variability in this range. So something to keep in mind with this data. Okay, next takeaway is the process for estimation. So they define 4 estimation processes. A process called lightweight Scrum, which is essentially just using story points for estimation. The process which is calling full Scrum, which is using story points and task hours for the estimations the teams are using. And then, of course, no estimate, and then only task hours, hourly task. So in that, it looks like lightweight Scrum seems to be the most overall balanced in terms of performance. And we'll talk more about estimation, very important topic. Next one is co-located versus distributed teams. So in this case, from all the way on the left being single open space team location, to all the way completely geographically distributed across more than 3-hour time zone difference, like most of our work tends to be with India time zone and US time, various US time zones and all that. So the interesting finding here in this data is that teams distributed in the same time zone have the highest productivity, significantly higher productivity. And the argument here is it is even better than co-located teams in the same open space. And the idea they're not distracted, that's the explanation he gives. They're not distracted even if you're working from home, so long as you're in the same time zone, seems to be highly productive. What I found particularly interesting here is the extreme cases of single open space versus all the way multi-time zone distribution. Doesn't appear to be that big a difference in the productivity measure. So you can do that far out. So, and of course, there's huge variability within each. So everything, you can be distributed and be quite productive essentially. So the last data-related takeaway was stable and dedicated teams. So this defined a little score of how dedicated the teams are. I can't go into detail, but on the right, with 80 to 100 are more dedicated and stable teams, and on the left are less stable teams essentially. So stable teams get 60% higher productivity and 40% better predictability. But the data seems to show that even otherwise, 1 in every team, 1 in 3 months, you have a change in a team. So there's generally a level of churn inherent in teams. So stable teams, of course, are better. This is something we've known, but it's good to see supporting data. So those are the main takeaways from this one. When I go to the next one now.
So how many of you are working for companies that are moving from monoliths to microservices? Yeah, so I see a few hands up there. So, it has become very fashionable to move to microservices, and we have to understand that it involves a lot of work, and there are a lot of challenges in doing so. And there are some good points of monoliths that we should not ignore before we move to microservices. So the first thing is a monolith works within the same CPU, within the same, you can say, operating system. So because of which the communication is at the speed of light, right? You're talking where one method calls another method. That is very different and much faster as compared to one microservice calling another microservice over HTTP using JSON. So there is a difference of 45x in the speed at which these calls happen. So this is the first advantage that you should keep in mind, that you will lose if you move from monolith to microservice. The second one is it's easy to move and change because what you're doing is you're changing in the same jar or same class or same package. So it's not that you have to deploy a separate Docker container and create an image for that and all. That is not needed. All you're doing is you're making changes and moving code from one package to another package. It's much easier. Dependent code also can be found. So if you want to find dependencies, then all you need to do is to make a deliberate compiler and see what else fails to compile if you push something to not compile. So dependencies can be easily found, or that's not true if you have separate apps or separate microservices. Tracking and monitoring, you have a single time series of log. So it's a chronological log, and you will be able to trace what is wrong by just reading the log. Now imagine in case of microservices, you have those several hundred logs running in parallel. One microservice calling the other, calling the next. So it becomes very hard for you to debug or trace or monitor by reading multiple logs. So that's another advantage. Adding new features is very fast, but then very soon that becomes a disadvantage because your ball of mud becomes very feature rich. So these are some of the advantages. One should keep in mind that you would be foregoing those in case you go for microservices. Now let's take a look at the advantages of microservices. So one thing is it might be slow, the communication might be slow, but you can create multiple instances of the microservice, and that's the way you can scale, which is not possible in case of monoliths. You can keep things apart, and you can have separation of concerns, and prevent it from becoming unmaintainable. So eventually, adding new features doesn't introduce a lot of regression. So because these things tend to stay independent. You deploy changes for just one thing. So you have come across a situation where even if there's a small change and it's a request from a customer, you have to ask the customer to wait for several days or so for a week or 2 weeks before it can be deployed. So that kind of thing is not needed. You can do continuous deployment much more easily in case it's a microservice, because what you're changing is a small thing by itself, and you can that way deal with technical debt, making refactoring decisions also. You can make really bold refactoring decisions with microservices. So this is a short comparison, and I thought that I would share it with you. It was done by Ryan Bergman. Now, if you have a monolith, then what are the prerequisites of the monolith before you move to microservices? So it's not like you have a bad monolith and then overnight you will have, if you move to microservices, you will have good microservices. Unless your monolith itself evolves and you have a good monolith, you should not consider moving to microservices. There is some level of maturity that is required inside the monolith. So what are those prerequisites? So first thing is the culture. You have to have DevOps culture, and you have to be able to take advantage of moving to microservices, as I said earlier. So if you're doing a continuous delivery, continuous deployment, and continuous testing pipeline, then only you get the advantage of moving to microservices. So if you're not doing that, if you don't have the DevOps culture, and if you're going to move to microservices and deploy it once in a year, you're not getting the full advantage of moving to microservices. Second is when you take the monolith, refactor it, and instead of, I'll show you this by the picture. So instead of grouping the code by framework, instead of horizontal slices, use domain-driven design concepts to group it by related domain or features. So I'll show it to you with a picture. That picture is following in the next slide. You use tools like Structure 101 Studio for Java to view and fix programmatic complexity. So you run some kind of analysis, static analysis tool, and you see a lot of complexity in your code, then you fix it. Instead of that, if you have your IDE, such as Structure 101, you are able to visualize that complexity and fix it right there. So so this is what I was talking about. So this refactoring of the monolith. So if you have a horizontal n-layered architecture, typical, where you have front-end, middleware, back-end, Angular in front-end, Java in the middleware, and Hibernate in back-end, you need to move that to a vertical kind of grouping of code. So you have functionality such as sign-up, search, order, and just put some hypothetical functionality there. So you have to move from what you see on the left to what you see on the right. So this is one way to do it is to group by bond. So I don't know how many of you have read this book by Eric Evans. It's a very good book, Domain-Driven Design. So this domain-driven design is talking about grouping code by bounded context. Bounded context has something, it's like you can think of your entire code base as a city, and then you are going to divide that into various suburbs and various areas. So like in this case, if you have an application which has various components, you can group them by packaging and delivery is a shipping subdomain, purchasing, bundles and claiming, that is sales subdomain, and you have legacy context for the inventory and ERP solution. So you can group the code using these kind of bonded context. So all this, what we are doing is to, to separate out things which are, reduce the dependencies across as much as possible, so that eventually these can be graduated to become microservices. Other way of doing it is by doing dependency inversion. So, like example here, so you have a direct relationship between a switch and a light, so it is hard coded, right? So instead of that, you have an interface, which is a button interface, and then you have a client which subscribes to that. So the client called bulb subscribe to the switch, and then switch on or off is an event which is published, and all the subscribers, there may be 1 or 2 or 3 subscribers, they get to know about it. So this is the way you separate out code, which is otherwise hard-coded and dependent, into separate packages. Once you separate it out, then you actually put it in separate packages, extract it, and put it in maybe in jars or Ruby gems or Python package indexes. And that is when your monolith is ready to become move to microservices. So these are some of the steps. So if you don't take these steps, if you have a bad monolith, you are going to have bad microservices. So you will not get the full advantage of it. So this was good learning. So with that, I'll let Hemant cover the next one.
Our next takeaway was this topic of probabilistic estimations. Those of you who attended last year, I covered this as one of the takeaways last year, and this is a repeat from last year because it got covered again. There was a session by Adam Ured, and there was a keynote address by this person, Troy Majanis. I don't know if you followed his work. He has done a lot of work on bringing this topic of statistical and probabilistic approach to estimating effort for software projects. So that's what I'll cover as a highlight. So in this case, the main observation is that when teams sit down to estimate a project, while there's a value when they sit and they're debating the detailed estimate, whether they do only at story point level or story point plus task breakdown, hours and all that, there's a real value when teams debate that this story is 1 point versus 13 point, right? You discuss it with each other and no doubt about that. But what turns out is the actual estimate that results out of the exercise is not very useful. They end up spending a lot of time on this effort. So a better approach that I'll describe here is a statistical way of approaching, of estimating your software effort. And in most cases, wherever the points make sense, I mentioned there's this link to the spreadsheet. You guys will have access to this PowerPoint, but let me describe the process. So what really happens is if a developer says, look, this story is 1 point, what they're actually counting is the amount of work here in the solid color orange. These are 2 blocks of work that they're counting. That's why they call it a 1 point story. Another story which the developer says is 13 points because they're counting the solid amount of work illustrated here. Because there's more work, this is a 13-point story. In reality, if you look at the elapsed time, they both take, let's say in this example, 20 minutes to get done. Because the story is not getting done because of the wait time. This hashed area is the wait time. That is, you're stuck, or you're waiting, or you're dependent on another developer or a team. So your elapsed time for the output to come out at the other end, the working feature, is still 20 minutes in this case. So the actual estimate that developer gives is just not that useful in coming up with the actual predicting how long it will actually take the project if you add up all the stories. So a better approach, so this is an illustration of the same idea. It doesn't matter how fast you can go. If you're stuck behind others, you can't move. So this is just an illustration of the same idea. So the better approach is to use a statistical approach. So what Troy has done, he's put together the spreadsheet. It's in public domain. You can download it. So we walk through. You provide very simple input, very important inputs too. So for the project at hand, first thing you provide the start date. You input that field in there, whatever the start date. Of course, your completion date is a function of the start date at a minimum, nothing else. So that's important. Then you input your estimate of number of stories that you have in there. So guesses this is between 20 and 30 stories in this example. Simple input in that, right? For a project, you're estimating a project. Then your split ratio. If you've seen that stories as they go through the elaboration process and grooming process, they tend to split. You look at the historical data and you say, look, typically our split is 1 to 1.1 story becomes 1.5, or on average 1.5, or whatever. In this example, it is 1:1. So you just input that. again, look at your empirical data from recent work. Then you look at your recent data and estimate the throughput your team has been producing for per week. If they're doing, let's say, 1 to 5 story points or 1 to 5 stories per week or whatever the units are, just pick the units and put those in there. And then the spreadsheet does the work of essentially using probability Monte Carlo simulation with viable distribution curve, which I'll show you, which I learned at the conference, that this, unlike a normal distribution curve, which is even on both sides, this has a long tail, and this is a better way for the probability distribution of software projects. So if you do Monte Carlo simulation, which is being done behind the scene in the spreadsheet for you, using this probability distribution curve, you essentially get this output. So you'll get that in this case with 90% confidence, it will take 11 weeks, and therefore the project will get done on 17th of June, for example. So you provide those inputs and you get this output. This is far more reliable rather than taking individual bottom-up estimate for each developer, which ends up being the original finding I told you about Larry Macaron's work, which is story point estimates are better rather than detailed full scrum estimates and all that. So it kind of resonates with that. And all you need by way of sample, this is another illustration from the keynote of Troy. You only need 10 to 12 samples, recent samples of your team, throughput or whatever output measure you're using. So the information value of each additional sample is not that high. First sample, the empirical data you get from last week's sprint of the team is useful. Previous few weeks, even more useful. Once you get to 10 or 12 samples, 13 data point doesn't give you incremental new information about team's performance. So all you need is recent data. That's important, recent data. But real data from your Rally system or Jira, whatever you have. Just take those, input that into a spreadsheet, and use that. So here's the net when trying to forecast the projects. Use historical velocity or throughput data. Most recent 10 samples are adequate, delete all the rest. Because if you use older data, it ends up biasing or it's out of context. The team has changed or the nature of work has changed, so that those samples are not very useful. This is helpful action. So that's the takeaway from this. Can you get your mic icon?
Did they give any specifics when they used it and how well it kind of correlated with the actual results?
So he didn't present. So the question for those who couldn't hear, was there any evidence in the data how it correlates to using this technique, how well it correlates? I didn't see that. I mean, he's been presenting this work. I've been attending this conference for at least 8 years. For the last 3 or 4 years, he's been covering this work with Troy. So I would recommend you, let me go, the reference here. But I don't have that confirmation that you're asking for. That's a good question. Any other questions on this topic or estimation? Okay,
So how many of you have, two competing or multiple competing innovative projects, and how do you decide? How do you decide whether you should spend your budget on project X or project Y? It could be your next generation microservices project or doing artificial intelligence. There are several things that your organizations wants to disrupt or innovate in. So how do you decide? So innovation accounting is a topic which was covered by Eric Ries in his recent book that is on called The Startup Way. And there are several papers, one of them on innovation options by David Benetti. The same topic was covered here by another person, Joe Vallen. He is from this SAFE, so Scaling Agile team. So most of the times these decisions are made by HIPPO. HIPPO is like highest paid person's opinion, or squeaky wheel. Squeaky wheel is the one who makes maximum noise, gets his way. The next is FIFO. Since my project has been there first, let's it should be the first one. So, but none of these are really scientific ways of decision making as to where we should put the investment budget. You don't have infinite budget, so how do you attack this problem? I mean, one of the illogical things we always do, and that is we always look at sunk costs. We have already sunk $1 million in this project, so let's do that. Let's not open something else. So one of the lessons that we learned here was that whenever you are making a decision, forget what has happened in the past. Otherwise, you will never pivot, right? You will keep throwing good money after bad money. So if you have to take a decision, you have to do base it on matrix. And one of the metric. So this is I'm quoting Dan Reynolds, and so what he said was, if at all you are measuring something, you should measure the cost of delay. Cost of delay is one metric which is worth measuring. So cost of delay, as intuitively you can think of, is how much would it cost me if I don't deliver this project on time, right? So it is the loss of business value, right? That's one. The second is time criticality. So it's at times exponential. It's not a straight line. And then risk reduction or opportunity enablement. So there could be a loss of profit. There is an event, and you have to take into account that in terms of risk reduction or opportunity enablement. So it could be those things. And then you have to compare it with the job size. So it's not just the cost of delay, but also how much it is going to cost to deliver on time. So there's a lot of competition, right? So instead of that, what we do, I'll tell you, is draw ships and anchors. So so all the stakeholders go in a room, and on a whiteboard, they draw ships and anchors. A ship shows the value that a project is delivering, and the anchor shows the cost associated with that. And then it becomes obvious to us by looking at the whiteboard that we should be going after big ships with small anchors. So that's essentially what this formula talks about. But innovation accounting also means that we need to look at things which are going to happen in future by observing something that is happening currently. So which means we have to take into account the process. So all the old discounted cash flow type of metrics like NPV, IRR, etc., they are after the effect. They are lagging indicators. So you can't really do much with those because it's hard to predict what the net present value of an innovation project will be. You don't even know whether it is going to pan out the way you expected it to. So in fact, the right way to look at it is you start by building a minimum viable product, then evaluate that. Now, if it satisfies the evaluation criteria, you continue implementing additional features, and till the time your WSJF determines otherwise. So at some point of time, if you're spending too much as compared to the value you're getting, you stop doing that. Till that time, you keep building features into your minimum viable product. If in case at the evaluation or validation of minimum viable product itself fails, you decide to pivot. So don't look at the sunk cost, just decide to go with something else, change the idea itself. So these are some of the, I'll not go through the prerequisites of business agility, but there's one example of leading and lagging indicators. So if you're taking innovation projects such as an airline booking system, the innovation is that instead of having phone booking, you're moving to web-based booking online. So the indicators that you would look at are like, you look at what is the time that average call, what is the average number of calls, call center volume, or you look at the average calls for flight schedules. So you see these going down, and you see the visits to the site going up, right? And so what is to be observed here, these are going up in very steeply, and whereas this is falling not that steeply. So you could draw conclusions from that some people who were not our customers or not users are getting added because of this. So you should pursue this MVP and invest in it further. So these are some. So the hard part about these indicators is that there is no standard indicator. I mean, lagging indicators, you have standard, you have revenue, you have profit, you have NPV, IRR. These are all known standard 100-year-old things. But when it comes to leading indicators, a leading indicator will depend on what you're trying to validate. What is the value that you're trying to add? And it's a hard one. You'll find it hard to know or to determine or identify what should be the leading indicator. So with this, I'll let Hemant take to the next one.
Yeah, so the next takeaway for us is the topic of value over cost. So the observation that is the takeaway is the fact that most teams spend way more time in trying to appearing to get precise estimate of the cost. And I just talked a lot about estimation techniques and all that. But they don't really spend enough time of same rigor on the value of each story. So the same project, you've got 30 stories in it, you're spending so much time figuring out how much it's going to cost time and dollar effort to build those 30 stories, but nobody questions, are these all the right 30 stories? Should we prioritize them? Which is the highest priority, so not get lost in that. So the advice is to this, just like you do a planning poker session and use that, let's say the story point level to come up with the effort estimate for the scope of work that you're putting into that sprint. What you should do is do a similar exercise of a planning poker like, but this time what you have in the room are all business stakeholders. You may have your executive, you may have salesperson, you may have product manager, people who are essentially representing maybe even some sort of a proxy customer, and then let them debate these stories, the value of each of these stories, and then force rank them first, all these stories based on business value priority, and then assign story value points, just like you do the Fibonacci series or modified Fibonacci series points, same cards, use the same cards, but just now assign, this is the one value point story versus the 13 value point story, and do that exercise. And the important thing is to do these two exercises independently. Do the value point exercise completely independent of the effort estimate exercise that the team is going to do. And then, as the product owner, that facilitation session that is happening is being facilitated by the product owner. So the product owner is then listening to this conversation when a sales guy says, look, this story is 13 points because I can close the deal on this basis. Because this feature was there, I would close the deal. And then, the executive questions that, look, the last time you didn't do that, what happened? So they start debating. So in that debate, clarity happens on the value. And the product owner starts understanding the rationale behind the story. And that never happens these days. So the idea is to do those exercises, and then independently, once you have them, the things which are high value points and low cost, you can think of them as quick wins, get them done first. They're the highest priority. So assign priority based on that ratio, and things which are high value but also high cost, try to break those stories down. Those are good candidates to break down, so you find where is the gold, where is the value in those bigger stories. This is a good way to prioritize. Here's the visual of what we did in that exercise. We had hypothetical stories for a home remodeling project, and we rank them and then assign value points. And just within half an hour, 45 minutes, you can get to this exercise in a very useful way. Here are a couple more pages to illustrate the frame point. So this was from Jeff Sutherland's session. I'll cover his session on Scrum at Scale in a few minutes. But his assertion is that today only 25% of the staff is working on stories which are high value. The rest of the stuff are junk stories or zero value stories. So there's a lot of waste happening right now building stuff that actually is either not validated, hasn't passed through customer validation, so the fact is needed, or it's just not high value stuff. You just end up in a backlog, you start doing it, you wasted effort. So, and here's another illustration that in the keynote address from Troy, he talked about that the analytical efforts that is spent, most of it is spent on status reporting, selection and prioritization of stories, not enough on customer validation part. So I think that's the missing piece that we find a lot of teams are stuck with right now. So that's the takeaway, value over cost.
So throughout the conference, you see this importance to customer validation that is coming in again and again. Value, business value, customer validation. So, how many of you have heard or read the book called The Lean Startup? So I see quite a few hands being raised there. So Lean Startup was 2011 published, and Jürgen Apello, like you and me, read that book, and he started questioning, since I've read the book, let me do my own startup. And he did his own startup, and then he discovered a lot of new things which he shared in this session. What he says is that it's actually just build, measure, and learn is what Eric Ries has talked about in the book, is not everything. So you have to have a conceptualization step added to that you have to first conceptualize what you're trying to build, and that is important. Then empathize, we'll be talking about it, go to the customer, visit them, understand. Your idea really comes to in your head, the light bulb glows only when you are in conversation with an end user or a customer. So empathizing, synthesizing, coming up with a lot of ideas to solve what the customer pain point is, then narrowing them, and then coming up with a hypothesis, and then you build, measure, learn, and then continue that loop. So this is, a combination of design thinking and his own conceptualized step and the lean startup thinking. Other thing that he discovered was hiring. Lean startup doesn't talk about hiring at all. And what he says is hiring for a startup is, I don't know how many of you are entrepreneurs. It's so difficult. Try convincing your friend to join your startup. It's very difficult. So hiring is one of the most difficult things. So what he did in his startup, Jürgen Apello, they decided not to have an office and hire people globally, so that guaranteed some kind of diversity. Daily stand-up meetings, instead of that, they have what they call as daily cafe. So in daily cafe, they just, in a lean coffee way, they decide what is the topic to be discussed. 2 or 3 topics are shortlisted, and then they discuss those topics. So that's their daily cafe. And all the money that they save on not having an office is spent on having an exotic location, and then they go and get together every quarter there. So that is how they do their team building. And they're very, very careful while adding or selecting people by just eliminating wrong candidates very early in the recruitment funnel. So these are some of the learnings of the hiring process followed by him. Also crowdfunding. So the Lean Startup book doesn't talk about funding. How do you raise money? So crowdfunding is a way which he found to be very attractive, because if you take money from hundreds of people, they automatically become invested in your venture and they become your advocates. Going the VC route is unagile, because once you sign up and the VC funds your story, it's very hard to wait for the last up. You can't take $1 million from a VC and tell him that, look, I'll keep it till I find the right time to invest it. You have to start delivering right after the day one. The meter is down and you have to start doing things. Crowdfunding platforms like what he has shown here, these are some of the crowdfunding platforms that he has used, and they charge about 5 to 10%. So that is something for those of you who are thinking of raising money, can make a note of that. So these are some of the golden nuggets. Most startups fail because they start scaling without validating. So the moment you have the first few customers, instead of learning from what didn't work with those customers, you're happy with what worked and you start scaling. So what is important is complete validation. C, stabilize. So he has included a stabilize step here in the startup, right? So stabilize before you scale. So that is an important learning. Also, there was a framework by Ash Maurya called the Lean Canvas. So he has modified that Lean Canvas. So the Lean Canvas looks like this. So on the canvas, you have boxes and you follow the steps by filling in those boxes. Now it looks very waterfallish, right? You can't go to step 2 unless you have completed step 1. So he changed this framework to this, wherein you can have some steps running in parallel, right? Like you can see the step of customer segment or problem. So it's not like your problem definition doesn't end. It is a continuous process that you may go to the solution and find that you don't have a correct solution and you redefine the problem. So it's more like a Gantt chart or a sequence diagram than a boxed canvas like this. This is very insightful, and I think this tool would definitely look more realistic than this one, the other one. So yeah, these were the takeaways from Jürgen Appel. Very insightful. With this, I'll let Hemant cover the next one.
So the next takeaway is this topic of Scrum at scale. So many of you are familiar with the idea of there are many scaling frameworks. Once you go beyond a few teams to tens of teams, and in some cases hundreds and thousands of teams, you need some sort of framework. So there are half a dozen or so frameworks in the Agile community. The most common one, of course, most of you probably have heard of is Scaled Agile Framework, SAFe, by Dean Leffingwell. And you know, they're still pretty popular, it's around, but what was the key takeaway in the conference this year was there is a certain amount of flag that SAFe gets that it is too bureaucratic. If you look at any of the SAFe pictures, say version 4 is the version control framework, has three or four different variations of it based on the organization and all that. And for many organizations, it's a very comfortable, good way to plug executive level governance and complexity into an agile process. But what Jeff Sutherland, who is the co-creator of Scrum, he's offered what he promises to be a much more lighter weight and a linearly scalable framework called Scrum at Scale. So that's the takeaway, and I'll talk a little more about that. So these are the recent coverage of his Scrum at Scale framework. On the left is Scrum at Scale guide, again publicly available. You can download it. Came out earlier this year, and then May-June issue of Harvard Business Review. He has co-authored this article on Scrum at Scale, which essentially covers the same idea. So you can look into that also. So it's a recent topic, and essentially the essence of his idea is to achieve linear scalability without too much overhead that other scaling frameworks seem to have. And he could define scaling on two levels: operational scalability, which is being able to deliver in a scalable way, and then strategic scalability, which is able to extract market value in a scalable way. And he defines these two core kind of loops in this framework: a Scrum Master cycle with the executive action team to take out roadblocks related to delivery, and a product owner cycle, which has executive meta Scrum that he calls to ruthlessly prioritize and deal with the product prioritization issue. And his core point is the main kind of a role to be played in scaling this is the product owner. The product owner has to be really the driver for what is being worked on and reduce the dependencies and all that stuff in larger teams. So this is the graphical picture of how he lays it out, but it's worth looking into this skill. I don't think I'll do justice to describe how this framework works, but it's worth looking into.
So the next topic is about experimentation. So Agile is all about experimentation, but how do you set up experiments? So there was a lot of learning from Christopher Lucian, Jenny Ranger, and Ian Maple. Ian Maple is from Intuit, and so you do design for delight at Intuit. This is the program, is what they call, and there are 3 steps that they follow in this. The first step is, as I said, empathizing with the customer. So having deep empathy by actually visiting customers, taking notes, photos, discovering, asking questions. Be a dummy. Don't have to make any statements which are judgmental, or actually ask for clarifications. Ask as many questions as you can. Don't make any suggestions or judgments. And then you go broad. That is the next step. So go broad is create as many ideas as possible. Brainstorming kind of session. They say ideas dime a dozen, and we actually created, some few hundred ideas in 3 minutes. Of course, there are several tables, and each table generated 10, 12, 15 ideas. So it is possible to generate a lot of ideas. Then what do you actually experiment with? So you have to go narrow. So going narrow is by having a grid. So you have two orthogonal words word pairs. So like speed and accuracy. So you draw a grid, low speed, high speed, low accuracy, high accuracy. And those ideas which are in the right hand top corner are the ones which should go to the next level. Similarly, you can have other word pairs like low cost, high cost, low innovation, high innovation. Simple, complex, and versatile and not versatile. And put your ideas in such quadrants, and then based on that you go narrow, and then narrow down, go narrowing till you come to two ideas, right? So that's when you do A/B testing. So let's talk about A/B testing. So A/B testing is a very so let me tell you typically what happens when you are trying to evaluate in an experiment a new project. What is the value that it is bringing? You run something, some change, and you evaluate it by seeing the customer metrics. Now, even if those customer metrics are not up to the mark, you always have some kind of rationalization. You know what happened? It was over the weekend, and this weekend there was a game, so that's why probably the number of visitors was not what we expected, but it is good enough. You need to factor that in. Or it could be the weather. It was bad weather because of which people really didn't turn up. Like I and Hemant were debating just before this thing started that it must be the traffic. That's why we don't have such good. Of course, now we have a good turnout. So. You always, our human mind always tries to rationalize things, right? So in A/B testing, that is taken away. So you have two cohorts, and those two cohorts are simultaneously exposed to the same weather, same traffic conditions, same promotions, same external events. So you have no, you don't really need to rationalize, right? So then you have a very good comparison between two. Similarly, you have bugs. You often say that, okay, there was this bug, so we need to fix the bug before we get the real metrics, right? When the bug is fixed, you will really see good response. But if you have the bug impacting both your A cohort as well as B cohort, you don't really need to fix the bug before concluding. Your decision can be made because the bug was equally impacting the A as well as the B cohort. So you have to be careful with data though. Data can be imprecise. So again, coming back to we tend to be optimistic, particularly when we take a lot of efforts to build something. And one of the examples which Jenny Wanger gave was they were super excited about something that really worked very well, and in a couple of days, in 3 days, they got 25% increase in their uptake. And they were almost ready to throw a party, but they said, wait a minute, just let's take a look at the data. And when they looked at the data, they realized that they are double counted. So, you have to be very careful with data while doing A/B testing. So you have to decide what is good enough before you start and how you are going to measure, and then you actually stay honest to what you have decided once it is over, once the experiment is completed. With that, let me put.
So the next takeaway is this topic of myth of 10x developers. So I've been in software industry for well over 2 decades. I know many of you have been long enough in this industry. So there has been a myth of there is in fact sometimes 40x developer compared to in terms of performance. So from this session, Paying for Performance by Adam Ured, they've put us through this session, a game of red bead, white bead experiment. Any of you have played this game of red bead, white bead? Okay, so this is a very interesting experiment or a game to play. It models software development team and process. The idea is that you're trying to you have a bag full of red beads and white beads, and you're making some precise efforts to take out a sample out of it, and think of red beads as defects and white beads as working features, and you want to minimize the red beads. But regardless of how much individual performance rewards or penalties you may drive, there's a system has a certain proportion of those red beads in it, and you just within a band they will keep falling in. So maybe it's not exactly representative of real world, but it's close enough to illustrate the point. So the point is that variations exist in the system. That think of your software team as a system, right? It is a system, your constraints from your executives, from your kind of work you do and all that. And within that system, all workers are performing, your developers, your testers are performing in that system the individual try to optimize the system performance rather than the individual performance. And the individual rewards and penalties don't seem to work. So they illustrate with this example of on the vertical axis here, this is the pilots flying and the flight quality on some scale, high being good quality, low being bad quality of flight. And a pilot who had a good quality flight and you praise that pilot, their performance dropped next time for the next flight. And the pilot who had a poor performance in flight quality and they were criticized, their performance improved. And when you look carefully at the data, ultimately, in both cases, it is a regression to the mean. So you, as a manager, you may think like you're doing something and it is having an effect. In reality, it is not. So that's the main takeaway, is to not get carried away that individual performance actually has a role, but rather look at the big picture system. And here's the illustration of putting a 10x developer into a poor performing system is not going to go very far. So it's a good reality test of the myth of 10x developer.
Last year or year before, I had talked about Chaos Monkey. So Chaos Monkey shuts off servers in the Netflix network to test how resilient that network is, whether you have fast failover working or not. This time we talked about chaos engineering, which is we talked about an entire army of monkeys, simian army. So these are the monkeys in that simian army. Chaos, you already know, kills random instances. Chaos Gorilla kills entire zones. Chaos Kong kills regions. Latency degrades the network. Conformity looks for outliers. There are some good ones also. Circus doesn't know. It kills and launches instances to maintain zone balance. Doctor fixes unhealthy resources. Janitor cleans. Hauler just informs each other that something is going down, something is going up, etc. Security does security testing. So what is chaos engineering? Chaos engineering is basically, it's a hypothesis-driven experiment. And you have to hypothesize, which is a real-world situation, what would happen if, and that if should be, whatever follows if should be a real-world scenario that is likely to happen, right? So a region going down, or a server going down, or a particular file that has something which is corrupt getting into your list of files, so it is likely to make things slow. So these are, or internet becoming slow, bandwidth getting consumed by some kind of attack. So all these are things which can be simulated by this chaos engineering. So you have to do automated continuous experiment and then measure business metrics and outcomes that will be impacted. Also, you have to limit your blast radius. So you have to make sure that this simian army doesn't go out of hand and just bring down everything. So you have to control that blast radius and make it as real as possible by testing these things in production. Also, you have to identify what will you break first. The weakest link has to be identified. Don't forget to test people. So, he gave an example of a character in the book. There's a book called The Phoenix Project, right? So in that there is a character called Brent. He has this uncanny knack of breaking anything that he touches. So just find out if there is a Brent in your team, and just imagine if Brent were to do his latest and greatest code checked in, then what is likely to happen? Simulate that. So these are some of the scenarios which you should imagine. And other thing is adding tools. Every time you add a tool, it increases the dependencies and chances of failure increase. So 2 to the power of n is how you would calculate the chances of failure, n being the number of dependencies. So that's chaos engineering. That was my last takeaway. I'll let Hemant handle his.
Yes. Before I go to the final one, Jill, I think, has something to give away, I think.
Hello. Yeah, just to keep it a little bit of a break, we have our 5 water bottles. Does anybody not have a raffle ticket? Would you like one? You lost yours. They found 3. So I'll let you choose one of these. There you go. Anybody else not have one? Can you hand some out to these guys? Thanks. Yeah, slip through. It's very scientific in my basket of a plate.
This is a red bead experiment.
It is. Thank you. Okay, so the first winner is number ending in 5426661. So this one goes to me. Okay, great. My kids love these. Okay, so the next one is 5426675. Yay! I'll bring it up to you. The next one is 5426628. Yay! There you go. I don't need that. Then the third one goes to 5426630. Yay! Thanks. And then we have 5426625. Okay, I'll bring it up in a second. And then the last one goes to 5426633. Yay, thank you very much. And then on to number 12.
All right, good. Let's go on. Fine. All right, so let's finish up. This is the last main takeaway, and then we have a couple of straggling ones that we'll quickly cover. So this was the topic of Agile metrics. So as I said, there was a full track this year on Agile metrics, and this is a topic we struggle a lot working with our clients. What's the right set of metric or metrics to measure for a team? So there were at least 3 sessions that I attended. There are a few more. So I'll refer them all. You can look them up. One is this whole discussion around outcome versus output focus in software development. You know, in medical and healthcare, they talk a lot about outcome and all that. This is the first year I heard this discussion in software teams. Next one was a goal question metric framework by John Tanner, and then last one is the same guy, Larry Macaron, whose data I shared with you. He proposed this outcome, decision, insight, measure. So net of all this, I boil it down to that, and the takeaway is essentially this, that the guidance is that we got to pick a set of balanced competing metrics, because it is easy if you pick just one metric to measure a team. Remember, we just talked about, think of it as a system. You're measuring the performance of your team, which is a system. So you're doing it at a team level. But if you pick one metric, it is easy to gain. If you just think of quality, then you can give up, you can take a hit on productivity or cycle time and improve quality, right? So have 4, these are the 4 recommended balancing criteria. So first, again, no particular order, is how well is your team doing, the quality of their output. So you can be things like defect density, or more common one is escape defects. So pick one of those metrics. So let's say escape defects in this case. Second is how much is the team delivering? Number of stories per sprint, or number of story points per sprint, whatever. So volume of output. Third is how fast the cycle time, which is when a story gets into the backlog to the time it gets into your customer hands. So that's a cycle time. So take a cycle time metric, let's say. And then fourth is the predictability, how stable is teams, how much can an executive or manager rely upon a team's ability to deliver? Are they consistent in their delivery? So pick one from each category and look at a trend. So don't look at a snapshot, look at over time. So look at a team level, look at these 4 metrics, these are competing. So if you gave one, it will show up in the other one. So you can see, and it's okay to make trade-offs that because you're having customer issues, you're going to overcorrect for quality while taking a hit on productivity. And it's okay to make that as a conscious decision as a team. And then pick at least one from each of these. Here's the illustration of a typical dashboard, which has one for each, one for quality, another one for responsiveness, predictability, and productivity. And these are all trending over time. And then you can see how your team's overall system is performing across. And here's another example that I recently have come across that I found useful. This is not from Agile this year's conference, but it largely aligned to that. So I thought it's worth sharing with this group. These metrics are cycle time, escape defects, plan to done ratio, which is essentially predictability, which is how much consistently team is getting done. And then this one includes the happiness metric, which is important. You think about, we talk in software development, sustainable pace. So this is an interesting one. This one is missing the cycle time, or missing the productivity metric in this. So anyway, so those are the net advice from Troy. This is the guy who's done a lot of work on metrics and statistical analysis. Is this main kind of to go for trends, not numbers, team, not individuals, multiple, not single metric, and applied in your context. So in your context, maybe you take a hit on quality because you are trying to get to product faster to market to capture market opportunities. That's okay in your context. So those are the main takeaways. With that, now we'll just take quick turns to cover a couple of smaller takeaways which didn't warrant a page by itself.
Right. So, like Hemant quotes Troy, I keep quoting Don Bennett said. So one of his quotable quotes is, "You may ignore economics, but economics won't ignore you." The second one is by Amr Noman. This is an Egyptian practitioner who actually practiced mob programming. Mob programming, last year we had talked about it. It's like, the entire group of developers or the team sitting in a room with only one keyboard and one mouse. Now, if there are 5 developers, you're thinking, common sense would tell you that it would be 1/5 as effective because there's only one keyboard and one mouse. But in reality, it is proved that whether they are working solo or whether they are working in group, the productivity doesn't get impacted. In fact, if it's a initial design architecture kind of work, when they're working in a group, they're more productive than if they're working solo. So that was a good takeaway I thought I'd share with you. Share your forecasts so frequently. So if you're doing estimation like Hemant was telling, with that whatever forecasts you have, you share them so frequently that clients would stop asking when is the release date. So do it continuously. Dom Price in his keynote said, "A fool with a tool is still a fool." Christoph Lucian about experiments. You're experimenting all the time. In fact, unintentional experiments are happening all the time. So keep track of things even if there is no immediate use. You may be required to use that data in future. So you should recognize those unintentional experiments. So, Hemant.
All right, my last 2 straggling takeaways were very simple, small ones. The first one was this topic of business agility. I'm assuming most of you have heard of it, but this last year at the conference, there was a lot of talk about applying Agile across other functions other than software development, in marketing, finance, HR, and all that. This year, there was a big talk of enterprise, essentially what they call business agility. I've come to understand as an enterprise-wide agility, meaning at all functions level, at executive level, everybody is just following that Scrum or Kanban style Agile mindset and Agile belief system. And that's enterprise-wide agility, and that's becoming now Scrum. Even the Harvard Business Review article I alluded to kind of speaks to that topic. That's one takeaway. The next one was actually particularly from a session by a couple of guys from Accenture. They talk about using AI like a Siri, AI-assisted Scrum Master. So it's a virtual Scrum Master that is helping based on the data it is reading from your Rally system or your Jira system. It is becoming more smart about asking the right questions in the daily stand-up and prompting the Scrum Master to ask the right questions and taking it further. So they built a tool called My Wizard. Essentially, it makes, so you guys can read up on this. But it's an interesting idea now you have the data in your ALN system, why not leverage that to be a smart Scrum Master? So those are all our takeaways. We'll hang around if you have any questions for a few more minutes. And you're welcome to, I'm not sure if there's more pizza outside and all that, but this is it. Thanks, guys.
Please turn in your comment cards on your way out. Forget it.
Yeah, please drop off your comment cards on your way out.
No, they start back.
Thank you for coming. We hope to see you next month at our 10th anniversary, September 20th.
I'll tell her.
He's doing good. He's doing good. I'm not there anymore.
Yeah.